Next, we're going to look at scientific notation. Scientific notation, in my opinion, looks very intimidating if it's the first time you've ever seen it, but I will compare it to just abbreviating long words. We do this very often. If we have a long, complicated word, we might just use its abbreviation. And that's exactly what we do with numbers. We're going to abbreviate them using this system, converting very large numbers or very small numbers. So move the decimal so that one non-zero number in front of the decimal point. Write this number times the corresponding power of 10. Examples of correct scientific notation: 1.23 times 10 to the second, 5.1 times 10 to the ninth, 3.007 times 10 to the negative 6, 6.6802 times 10 to the negative 100. These are examples of what scientific notation looks like. Let's do some converting for ourselves. So we wouldn't normally convert the number 1, but I just wanted to show you. So 1 times 10 to the 0th is how we would write the number 1. So we have 0 zeros for the number 1, and you can see 10 to the 0th, right? With the number 10, we only have 1 0. So we have 1 times 10 to the first. You see that only has one exponent there. 100 has 2 zeros, so we see 2 is the exponent. 1000 has 3 zeros, so of course there is 3 as the exponent. 10,000 is 10 to the 4th. Makes sense. 5 zeros, 100,000 is 10 to the 5th. A million is times 10 to the 6th, and a billion is times 10 to the 9th. Okay, so you can see we're just counting those zeros. What if you went the other way? So 1 is still 1 times 10 to the 0th, but what about 1/10? Okay, there's still 1 0, but how do you write that? So you write 10 to the negative first. 100th would be 10 to the negative second. We're counting the zeros to the left. 1/1000th is 10 to the negative third. 10,000th would be 10 to the negative fourth. 1/100,000 is 10 to the negative fifth. And 1/1,000,000th is 10 to the negative sixth. And of course 1/1,000,000,000th, same thing, just negative 9 in the exponent. So it's not that bad. We're just rewriting this. We're using this to abbreviate the numbers. Let's look at normal numbers, sometimes referred to as standard numbers, and try to convert this to scientific notation. So 32,000 would be written as 3.2 times 10 to the 4th. We always just put one number to the left of the decimal place that's non-zero. So in this case, it has to be a 3. So it's not 32 times 10 to the third, it's 3.2 times 10 to the 4th. Same thing, 3.2 times 10 to the 5th. And over here we're going the other way, 2.2 times 10 to the negative third. And here would be 4.04 times 10 to the negative 4th. So you can see we just have to move that decimal place and count the zeros. What about 12,000? Again, one number to the left of the decimal place, 1.2 times 10 to the 4th. 62.1 billion, billion is times 10 to the 9th, but we have to move the decimal place, so there's only one number to the left that's non-zero, so 6.21 times 10 to the 10th. Here we move the decimal place over, just count the number of zeros, 8.41 times 10 to the negative 5th. Same thing, move the decimal place, so 9.009 times 10 to the negative 7th. Okay, some rules of calculating scientific notation. When dealing with scientific notation, you can multiply or divide the numbers by keeping the times 10 to the n in your answer. When multiplying numbers in scientific notation, the exponents are added. When divided, they're subtracted. Let's look at an example. Multiply 1.1 times 10 to the second with 6.7 times 10 to the 4th. Okay, so the first thing is just multiply those numbers. 1.1 times 6.7 is 7.37. Okay, so we just multiply them normally. We're multiplying these, so we add the exponents. 2 plus 4 is 6. So that if we round, this would be 7.4 times 10 to the 6th. All right, let's multiply these numbers. 5.5 times 10 to the 3rd, 6.0 times 10 to the 4th. Let's multiply the numbers to the left. 5.5 times 6, well, 5 times 6 is 30, so 33, that makes sense. We add the exponents, 10 to the 3rd, 10 to the 4th, 3 plus 4 is 7, but we have to correct it. So it would be 33 times 10 to the 7th, but correct answer would be 3.3 times 10 to the 8th because we have to adjust it. Divide 6.92 times 10 to the 16th by 5 times 10 to the 13th. Again, we're dividing, not multiplying this time. So we divide the numbers in front, see what happens. We get 1.384. We're going to divide the times 10 to the exponent, so that means we need to subtract the exponents. 16 minus 13 is 3, so we get 1.4 times 10 to the 3rd. Okay, divide 1.99 times 10 to the 6th by 4.2 times 10 to the 1st. So we divide as normal. We see, okay, we get 0.4738. Okay. We divide also the times 10 to the number, which means we have to subtract, but we also have to adjust. So it would be times 10 to the 5th, but we have to move the decimal place, so it's 4.74 times 10 to the 4th. We have to make those adjustments.